Now that we have our structured foundation, let's build our second agent, the Health Analyst Agent. Again, in Claude Desktop, each project becomes a specialized agent with its unique capabilities. I'll configure this with the same Claude model, Opus 4, but now I'm uploading different agent instructions. These focus on data ingestion, Snowflake integration, and health analytics. I'm also uploading visualization guidelines to the agent's knowledge that will guide the agent in creating compelling interactive charts that we'll see shortly. But here's what makes this agent special: the tools. Out of the box, Claude Desktop provides standard tools like web search and email. But below, we see something powerful: MCP servers. Model Context Protocol, or MCP, lets us connect Claude to any system or database. I've configured two MCP servers here. First, the Anthropic File System MCP. This gives our agent access to read the extraction files we just created. Second, our custom Snowflake MCP server. This is the magic. I built this to give Claude two specialized tools. One for importing health data into Snowflake's enterprise data platform, and another for executing natural language health queries through the Cortex Analyst endpoint. Now, let me ask what the agent can do. Perfect. It understands its dual mission: import health data into Snowflake, then enable conversational analytics. Now, I'll give it the location where our extracted files are stored. Using the file system MCP, it's scanning the directory and cataloging all our extraction files: lab results, vitals, medications, clinical data, everything we created with our first agent. Now the real magic happens. It's loading everything into Snowflake, creating database tables, establishing relationships between different data types, and building semantic models that enable Cortex Analyst to effectively convert natural language queries into precise SQL. Notice on the right panel, Claude is now analyzing the import results from the Snowflake tool call and creating a React code artifact. This is Claude's powerful code generation capability at work. It's building an interactive dashboard based on the actual data metrics returned from Snowflake. The React code artifact is now executing, and on the right panel, we see a comprehensive health dashboard rendered as a live web application. This interactive visualization shows our complete health landscape, over 2,400 records across 13 years, data distribution across 4 categories, and even year-over-year analysis of the various health metrics. Notice that spike in 2021? Well, that's when COVID health monitoring intensified. And 2017, that's when I had back surgery. You can see the medication surge. Now on the left, it's created structured data views and a health query guide. These components enable sophisticated health analytics through natural language. So let's ask our first question regarding cholesterol trends over the last decade. Notice something important. While I only mentioned cholesterol and triglycerides, the agent enhanced my request to include all key cholesterol metrics: total cholesterol, LDL, and HDL. This demonstrates the agent's intelligence in not just post-processing analytics, but pre-processing the request to provide comprehensive answers. The agent calls the Execute Health Query tool, coordinates with Cortex Analyst to generate the SQL, and returns results for visualization. The visualization reveals an interesting trend story with triglycerides. Back in December 2013, my triglycerides were dangerously high at over 400. Following that trend line across the decade, we see a steady decrease year over year. But then a concerning recent spike back up to 153 in 2025. This raises two questions. One, what caused the decade-long decrease? And number two, what caused the recent spike? Let's examine the medication patterns to solve our triglycerides mystery. The agent is pulling medication data and matching it with cholesterol trends over time. I can expand that tool call and we can see the generated SQL from the agent. This gives us a good opportunity to see what's happening behind the scenes in Snowflake Cortex Analyst. Here in the Cortex Analyst monitoring view, we can see the exact request from our agent and the SQL it generated. Look at this comprehensive query. It's joining medication tables and filtering for statins, fibrates, and medications prescribed for cholesterol or cardiovascular health. This thoroughness is what guarantees our results are accurate and reliable. Back to our dashboard, this visualization reveals the answer to our decade-long decrease. The steady improvement from 2013 to 2021 aligns with consistent statin therapy, particularly when optimized to 20 milligrams during 2020 to 2021. But here's the intriguing part. The statin dose decreased from 20 back to 5 over the last 4 years. However, this doesn't fully explain the recent spike since earlier years on 5mg showed stable numbers. We need more information. A1C, diabetes medication, and weight have changed together over time to solve this puzzle. Now we're correlating 3 different data sources: A1C labs, metformin dosing, and weight measurements across multiple years. Notice something remarkable. Claude Opus 4 breaks this complex question into strategic steps with multiple tool calls. First, metformin prescription history, then A1C results over time, and finally, weight measurements for correlation analysis. This reasoning loop showcases the advanced cognitive capabilities of Claude Opus 4. Here's our smoking gun. The timeline shows the complete story. Metformin worked initially, achieving the best A1C of 5.7% in February 2023, when weight dropped to 198 pounds. But then the weight gain overwhelmed the medication effect. The 27-pound gain from 2023 to 2025 directly correlates with A1C rising back to 6.1%. This explains our triglyceride mystery. It's not just about the statin dosing, it's about the weight-driven metabolic decline.